Hey class, today we're going to continue on with chapter 4 about the atomic structure. This goes on to our next concept known as isotopes. There are 3 different kinds of neon atoms here, and the book asks you, how do these atoms differ? So take a quick look at these and see what's different about them. Well, 1, they all have the same number of protons. Every single one of them has 10 protons. They also all have the same number of electrons, 10, 10, 10. What's different is the number of neutrons. So for example, this one has 10 neutrons, this one has 11 neutrons, and this one has 12 neutrons. Okay. So isotopes are actually defined as atoms that have the same number of protons, but different numbers of neutrons. So again, protons are the same, but neutrons are different. So here, neon 20, neon 21, and neon 22 are 3 different isotopes of one element. Okay. So the other thing that I also want to point out is, since the neutrons differ, I want to point out so does the mass number. So remember, this number over here is mass number. So mass number is different as well. And the reason your mass number is different, because remember, it's protons plus neutrons. So if that neutron number changes, so does that mass number change. And that's what's going to be kind of hinted at in this picture. How do isotopes of an element differ? Well, because they have different numbers of neutrons like we just talked about, they're going to have different mass numbers. One thing I do want to point out, though, is even though these isotopes differ in the number of neutrons, they actually are chemically alike, so they're still going to behave chemically the same. The reason is because their number of electrons did not change. Electrons are the ones that are responsible for chemical behavior. So as long as those stay the same, the chemical properties are going to stay the same as well. Okay. So remember the dogs at the beginning of the lesson? Their color or size doesn't change the fact that they're all dogs. Similarly, the number of neutrons does not change which element it is, because the atomic number does not change. Here's another example. It says diamonds are naturally occurring form of the element carbon. 2 stable isotopes of carbon are carbon-12 and carbon-13. And it says write the symbol for each of the isotopes using superscripts and subscripts to represent the mass number and the atomic number. So if I were to actually do that, carbon-12. So if I have carbon-12, my symbol for carbon would be C. Remember, this number right here is your mass number, so that always goes on top. And then what goes on bottom is my atomic number. So if you're looking at your periodic table, your atomic number on the one I provide in class is in your upper left-hand corner. And so for carbon, if you look at it, it would be 6. If you were to do carbon-13, you would still have C for carbon. 13 would be its mass number, and 6 would still be its atomic number. Now, if I were to take this a step further and ask you how many protons, neutrons, and electrons are in each isotope, we could do that as well. So remember, protons are equal to this bottom number, your mass number, which is 6. Electrons would also be equal to 6, since protons and electrons must equal. And then neutrons would be 12 minus 6 gives me 6. If I were to look at carbon, the protons would equal 6, since that's the atomic number. The electrons would also equal 6, since protons and electrons must equal. And then neutrons would be 13 minus 6, which would give me 7. So again, see how these isotopes differ in neutron number and mass number. Okay. So isotopes have the same number of protons but different numbers of neutrons. We've already talked about that. And the composition of an atom can be expressed by writing the symbol with the atomic number as the subscript and the mass number as the superscript, just like before. So again, we had carbon, 12 and 6. This is your mass number, and this is your atomic number. So subscript is below, and superscript is on top. So again, we just illustrated this on the other slide, but again, the book is showing you. So use the symbol, atomic number, and mass number to write it. We wrote it, and we thankfully got it correctly. So that's the end of the lesson. Let me know if you have any questions, and I hope you guys have a good day.